Hi, welcome to this lab. In this lab, we are going to learn TensorFlow Quick Start. So the overview here is you will learn the basic of Hello World of machine learning, where instead of programming explicit rules in a language such as Java or C++, you build a system that is trained on data to infer the rules that determine a relationship between the number. We'll consider the following problem. You are building a system that performs activity recognition for fitness tracking. You might have access to the speed at which a person is moving and attempted to infer their activity based on the speed using a conditional. So you can see that there's a condition saying that if the speed less than 4, the status is equal to walking. You could extend this to running with another condition if the speed less than 4 walking, but else will be a running status. Similarly, you can also detect with another condition. Right, so this time we added one more called cycling with another condition. Now consider what happens when you want to include an activity like golf. Now it becomes less obvious how to create a rule to determine the activity. It is extremely difficult to write a program expressed in the code that helps you detect the golfing activity. So what do? You can use machine learning to solve the problem. What is machine learning? In the previous section, you encounter a problem when you try to determine a user fitness activity. Consider building you hit the limitation, what you could achieve by writing more code, since your condition has to be more complex to detect an activity like a golf. So consider building the application in the traditional manner as represented in the following diagrams. You express the rules in programming language. This act on data and your program provide answer. In the case of activity detection, the rules the code you wrote to define the types of activity acted upon the data, the person movement speed in order to find an answer, the return value from the function for determining the activity status of the user, whether they were walking, running or biking. The process of detecting this activity via machine learning is very similar. Only the access are different. So you have the rules in the back, previously it was in the front, and then the answer actually as well, it has been swapped from the back to the front. So instead of trying to define the rules and expressing them in a programming language, you provide the answer, typically called label, along with the data. The machine then infers the rules that determine the relationship between the answer and the data. For example, in a machine learning context, your activity detection scenario might look like this. There are 4 diagrams here. First one is the label as walking, second one label as running, and then the third one is labeled as biking, the last one is labeled as the golfing or sort of. So you gather a lot of this data and label it to effectively say this is what walking looks like, this is what running looks like. Then from the data, the computer can infer the rules that determine what the distinct patterns that denote a particular activities are. So beyond being an alternative method to programming this scenario, this also gives you the ability to open up new scenarios such as golfing, which may not have been possible under the traditional rule-based programming approach. In the traditional programming, your code compiles into a binary file. That is typically called a program. In the machine learning, the item that you create from the data and label is called a model. Consider the result of the above be a model which is used like this as a runtime. So you pass the model some data and the model uses the rules that it infers from the training to come up with a prediction. The data looks like walking. The data looks like biking. In this lab, you will build a very simple Hello World model made up of the building block that can be used by any machine learning scenario. So we are going to open the workbench and then click on the Open Jupyter Lab. This from the instance. Okay, so I will want to install the TensorFlow and additional package, so I go to open the terminal here. Let's check the version. So the version for the Python version is 3.10.18, and I want to install the TensorFlow. I use this command. So TensorFlow is finished install, so I install my pip3 here using this command. And I also want to install the PyLink, which is a tool that check for error in Python code and highlight the syntactical and stylistic problems in your Python source code. So let's run that. So you notice I have some requirements file as well over here. Anyway, so let me just type in ls. You can see that requirements file is listed here. So inside this file, there is some dependency is already written. So I'm going to install this dependency here using this command. Now the task 2 is we will create our first machine learning model. So consider the following set of number. Can you see the relationship between them? Anyway, as you read from left to right, notice that the x value is increasing by 1, and correspondingly y value is increasing by 3. So the relationship should be y equal to 3x plus or minus some value. Then take look at the 0 on x and see the corresponding y value is 1. From both of these observations, you can determine that the relationship is y equal to 3x plus 1. This is almost exactly how you would use code to train a model known as a neural network to spot the pattern in the data. You use the data to train the neural network by feeding it with a set of x and a set of y. It should be able to figure out the relationship between them. So we are going to create a new notebook and import the library. So you go to File, go to New Launcher and choose the Python 3 notebook. And now we have a new Jupyter notebook is presented. So in the first and foremost, we want to import all these libraries here. The first one is the import logging, and the next one is the import Google Cloud Logging as the cloud logging. From Google Cloud Logging handler, import the cloud logging handler and also the v2 handler. And then we will import the TensorFlow for training and evaluating the model. We will call it TF for ease of use. Next, we will import the NumPy. To pass through the data for debugging purpose, we call it NP for ease of use. So to run the shell, you can either press Shift Enter and then it will run, or you can just click on the Run button here. I got an error. It says the module name is called Google Cloud Logging. Okay, so it can be because it's still installing in this terminal here, so we have to wait patiently. Okay, so I think the installation is done. So now let's go back to here and click on this run. Oh, I still get this error. Okay, let's see what happened. Yeah, I think I have already solved the problem with the logging library by installing just using one command like this and rerun this sales and it worked. So now I get this red color thing is a warning. I think you can ignore it. So now we will go to the next one, that is to add this following code. Right, so let's run this. So a Python library called the NumPy provide lots of array type data structure that are de facto standard way of feeding the data. To use this, so you will use this MP array function to store the value. Now the next one is we will design the model. In this section, you will design your model using TensorFlow. You will use machine learning algorithm called neural network to train your model. You will create the simple possible neural network. It has one layer, and that layer has one neuron. The neural network input is only one value at a time. Hence, the input shape must be a bracket 1. Right now is we will create the model first. From here. Okay. Let's run it again. Okay, I think I have a syntax that let's run it. Okay, I already put back the bracket and run. Therefore, I think it should work. So next one is we compile the model. You will write the code to compile your neural network. When you do this, you must specify two functions: a loss and an optimizer. If you have seen lots of max for machine learning, this is where you would use it. But tf.keras nicely encapsulate in the functions for you. From your previous examination, you know the relationship between the number is y equal to 3x plus 1. When the computer is trying to learn this relationship, it makes a guess, maybe y equal to 10x plus 10. The loss function measures that guess answer against the known correct answer and measure how well or how badly it did. So the next one is the model will use the optimizer function to make another guess based on the loss function result. It will try to minimize the loss. At the point, maybe it will come up with something like y equal to 5x plus 5. While this is still pretty bad, it is closer to the correct result. Then the loss will be lower. So the model repeat for the number of epochs you specify. So in this code snippets, you will tell the model to use the mean square error for the loss and the stochastic gradient descent SGD for the optimizer. You don't need to understand the max for this yet, but you will see how they work. Next, we will add this line. So training the neural network. To train the neural network to learn the relationship between x and y, you will use the model.feed. This function will train the model in a loop where you will make a guess, measure how good or bad it is, also known as the loss. You use the optimizer to make another guess. It will repeat this process for the number of epochs you specify, which is in this lab is 500. So now your file, well, should look like, the whole thing should look like this. I think yeah, it should be fine. Now let's run this. Yeah. After I run, look at the output. You notice the script prints out the loss for each epoch. Your output may be different from what you see here. So if you scroll through the epoch, you will see the loss value is quite large for the first time, but gets smaller with each step. As the training progresses, the loss gets very small. and by the time the training is done, the loss becomes extremely small, showing that our model is doing a great job of inferring the relationship between the number. You probably don't need all the 500 epochs. Try experimenting with different value. Looking at this example, the loss is really small after only 50 epochs. So finally, the 500 is the loss result. So using the model, you now have a model that has been trained to learn the relationship between x and y. You can use the model predict to figure out the y for the x not previously seen by the model during training. So example, if x equal to 10. Now say I'm going to add this 10 here. So your prediction result is passed to Cloud Logger in order to produce the cloud log, which can be checked for progress. Now I'm going to run this result. Yep, this is the Cloud Logger, and the y value is listed after the training. I think right now is I need to go back up here. To train the result. You can also stop the training by clicking the stop as well. Say you want to change to maybe 10. Let's see. So what is number 6? So the loss result is 22. You might have thought the y is equal to 31, but it ended up, differently. Neural networks deal with probability. It calculates there is a very high probability that the relationship between x and y is y equal to 2x plus 1. But with only 6 data points, it can't know for sure. As a result, the result for 10 is very close to 31. No, not necessarily 31. As you work with the neural network, you will see the pattern recurring. You will almost always deal with probability, not as certainties, and will do a little bit of coding to figure out what the result is based on the probability, particularly when it comes to classification. So congratulations, in this lab you have already created, train and test your own machine learning model using TensorFlow. You can end the lab now. Thank you.